That's good. Thank you. Hey guys, thanks for having me. It's good to be somewhat virtually back. I was there 10 years ago in the same room that you guys were in. I think doing these seminars are pretty cool. Very honored to be here, excited to be here, tell you about my journey, who I am and kind of how Michigan was special to me, always will be. So you guys are a special place and enjoy it while you're there because it goes by fast, but a lot of good times. So for me, I'm Andre Douglas, and right now I'm at the Johns Hopkins University Applied Physics Lab, and actually today is my last day. So I start NASA on Monday, so this is kind of a last minute chance to kind of get my thoughts out to you guys. So I'm a systems engineer at APL, and I was actually in the ocean systems group when I first got there. I was there for about 6 years, and then recently last year I was in the space exploration sector. So one of the cool things about APL I'll talk about is you're kind of based on your skills, you can kind of move around in different departments, different sectors based on what you want to do, which is really cool. So this is my presentation. As you can see down here, just trying to be funny, Michigan and beyond, a little Buzz Lightyear reference. And Michigan has really been a big part of my journey. So here we go. So just for the agenda today, a little bit about me, just a few slides, and then Coast Guard career, and then APL career, and then what's to come for NASA in the career, what that looks like. So obviously I haven't started yet, just got selected and I'll start next week, but I'll kind of give you a preview of what, typical training is just with a few slides. And then at the end, we can do some Q&A if you guys have questions. All right, so about me, I'm trying to move this video around so I can see everything. But I just want to start from pre-academy to the academy and college, current life, general interest. But I'm just like you guys, just grew up as a kid. Actually, for me, I was a military kid. So my parents were in the military, my dad being in the Coast Guard, my mom was in the Marine Corps. And I put Coast Guard there because my dad, he was the one that was kind of leading all the way, all the different places we went to. He was getting stationed in, Florida, where I was born, then up to Connecticut at the academy, then Virginia, New Jersey, all these different places. So for me as a kid, I was learning how to make new friends and doing certain things like basketball and soccer that were consistently, in new places so I could easily meet friends, things like that. I was always big into music. So I was a percussionist. I love drums. I love, playing good beats. And then even when I was, moving around a lot, one of the things I picked up was video games. So, back in the day when Halo first came out, that was one of the big ones that we used to play as first person shooters. I also love chess ever since I was a kid. My mom taught me when I was like 7 or 8, and it's been a big part of my life for kind of planning out my next steps. When you play chess, you're thinking 10 to 12 moves ahead, using strategy, different openings, things of that nature. And that all comes into play later for this presentation. But so growing up as a kid, moved around a lot, made a lot of friends, was very flexible, adaptable, loved sports. And then the academy, and I put academy/college because I don't know if a lot of people know about the military academies, but basically the Coast Guard Academy, it's a military academy where you go, you earn a 4-year degree. And for me, it was mechanical engineering. And then you actually commission as a commissioned officer in the Department of Defense or Department of Homeland Security like we did. So there I did a lot of stuff. I was a regimental commander. I actually got to go to the Air Force Academy first semester on exchange and got to do some skydiving there. So that was a lot of fun. Track and field, instead of doing basketball and soccer, I switched to track and field. And then I was a couple of different types of leadership positions and presidents at different clubs, things of that nature. As far as my current life, I mean, it's kind of interesting. I got married, had a great time meeting my wife in DC, and we have a son. His name's Mateus. We actually have another one on the way, due in May, so it'll be fun. In general, like to explore and network. It's been tough. I would say current life has been COVID life. So earlier in this presentation, I did something similar to another organization. I put like Zooming with friends because like I couldn't do that much as I used to last year. But as things started opening up, it's been different lately. But over the last year and a half, it's been a little bit tough. But definitely networking, exploring, working out whenever I can. And that's kind of like the daily life until I start with NASA. And then general interest, I've always been interested in space exploration, even as I, did naval architecture at Michigan. I always look at mentoring other people as I get into leadership positions and learn more about life. And I love to invest. So stocks, crypto, real estate, things of that nature. Definitely love traveling and some of the typical outdoor activities of hiking, kayaking, biking, things of that nature. So as you can see, some of the pictures here kind of describe the About Me section. So going into the Coast Guard. So after I graduated the academy, the first duty station I went to was in Cape Canaveral, Florida. And we actually did a bunch of, drug operations, search and rescue operations, alien interdiction, migrant operations. So we were on this ship called the Vigilant, which is stationed out of Cape Canaveral. Went down to Cuba, Haiti. We did all these operations. I was a, officer of the deck, which meant I had to drive the ship in the absence of the captain, electrical division head, an on-scene leader for flight operations, a damage control assistant, which was somebody that was the DCA is what they call it for short, is the naval architect of the ship. It's interesting when you go to DCA school, you're actually learning naval architecture in the Navy's DCA school, and they have that out in San Diego. So it was kind of neat where I got exposed to naval architecture before, I even went to Michigan to kind of see what stability was like, riding arm curves, things of that nature. But the Coast Guard relies heavily on naval architecture within their engineering departments. They send everybody to these schools to get smarter about it because, again, when you're out at sea for months at a time, you have to be able to understand how the ship responds in certain sea states, how to understand, when you have a helicopter on deck versus when your fuel tanks are empty on the port side, if you're going to do certain lists and things of that nature. So it's a really good, service to get some practical experience with naval architecture, not necessarily from the theoretical perspective like you do at NAME, but you get some formal training from the Navy, and then you can bring it into your world wherever you're doing on the ship. So, but the cool thing about this was being in the Coast Guard, they had this advanced education program, and what they do there is they'll send officers that perform well to graduate school. And that's where, Michigan came into my life. And I remember you can go to like almost any school you want to, as long as you apply and you get in. So there was always Michigan, MIT, and some of the other ones, Berkeley. But Michigan was cool because they had the dual degree program. So I was very adamant on going there to pick up 2 masters because I wanted to still understand and mechanical engineering, but then also get better at, naval architecture and marine engineering. So ended up going to Michigan. Coast Guard does a really good job with this because, and it's like a little hidden secret, they basically pay you your same salary as if you're like a captain on a ship just to go to Michigan, and they'll pay for your courses, they'll pay for your schooling. So it was a really good deal. So while I was there at NAME, we studied, we integrated with all the students. There's a big cadre of us, I think, back in 2010. So I think there were 12 different Coast Guard officers that went in all at the same time. We ended up hanging out a lot, and we would have I don't know if they still do this, but we had the big balloon in the tailgates at the football games, and everybody knew where to go to do all the big celebrations with Flip Cup and all this stuff. So we had a really good time just being at Michigan and doing that through the Coast Guard's program. And so while I was there, graduate school at Michigan, we had a lot of group assignments. I was doing some research with Professor Carr. If he's still there, we're doing some carbon fiber plate patching repair techniques. I remember doing TLP optimization with Matt Collette. And then, I just had a big network there of Coast Guard folks that we worked together in groups, we integrated with others, but it was just, I think that also made it a very interesting experience for the whole department because there was just a bunch of us that went through. So Michigan was great. I mean, even while I was there, as you see in this picture, I promoted from lieutenant junior grade to lieutenant, and they did it in the big house right there in the middle of the field. So that was a lot of fun. My buddy there, Pat Burnett, he's also a classmate of mine from the academy. So we got to do that together, which was really special. And so, after Michigan, the Coast Guard, since they sent us to Michigan for school, they actually put requirements on us to come back to the Coast Guard and serve out a specific tour to where we just learn skills to apply it to their, their needs. And so they have this place called the Marine Safety Center, where the Marine Safety Center is responsible for, certifying, cargo ships, all the commercial vessels, maritime vessels that are out there, from offshore drilling units, cruise ships, ferries, all of those things. So for us, we got to basically dive into the federal regulations to understand, what rules applied to what specific ships, what subchapters and what stability rules we had to follow when we had to analyze, small boats, things of that nature. We definitely collaborated with a lot of different regulatory agencies. So, ABS, as you guys might know from your classes, you're doing your section modulus calculations. ABS is like everywhere. So we work with them. I think it was DNV, GL, BV. We were working with a lot of them because, as we're developing new technology and new ships, there's a lot of, memorandums of understanding or memorandums of agreements that, where the Code of Federal Regulations occur, but then end, and then industry starts to pick up the slack or the unknown. You have to kind of merge these different rules and use best practices and best engineering judgment to come up with solutions for like novel vessels that are out there. I mean, for one example, with SpaceX, right, they were trying to get this barge approved. And I remember in my office, at the time, I think I was transitioning out and I had to get firewalled, so I couldn't review the barge, but they were trying to figure out how to, certify this autonomous drone ship, which wasn't in a regulation that had been, developed before. So we collaborated with a lot of different organizations to make that happen. So Marine Safety Center was a really neat place to kind of, take the things that we learned at Michigan, both from a technical perspective and just like organizational perspective, and apply that in the real, world with the Coast Guard. So also went to a bunch of conferences. We do stability analysis, but most importantly, I don't think a lot of people know about this little cadre of people at the Marine Safety Center, but if you see here, this acronym called CERT, it's Salvage Engineering Response Team. So I was a member of the CERT team as my collateral duty, where we're all salvage engineering, naval architects for the Coast Guard. We get trained specifically in salvage, and we'll go out to certain wrecks, certain disasters, and we have to provide the technical analysis for the captain of the ports to be able to make their decisions. And so it was a really cool job because, my day job at the Marine Safety Center, I was doing, so we're using GHS, General Hydrostatic Software. We use Hexsolve, and we do these reports, they're 300-page reports. You run your macros, you're doing all the stability analysis. And that can become routine. You're just getting a bunch of different owners of boats that say, hey, I need my crew, I got to get operatings during crab season. So, they put pressure on us to get that done. You're kind of going through the motions, everything's automated. But then when you do salvage, it's kind of like, hey, something happens unplanned, unexpected. Everybody stood at a duty day. So you'd have a whole day of duty. You had the phone where anybody from like around the world would call you, say they have an issue. So there would be Coast Guard officers and enlisted members in the maritime response centers around the world. So there's some in the US and there's some in activities far east out in Singapore. And if they don't know what to do when they have a derelict vessel or a grounding or a capsizing, they'll call us because they're like, hey, if we want to right this vessel, we want to raise it, we need some technical expertise. So they'll call us. And when they call us, we'll like make sure it's not just one person. We'll probably get a buddy to make sure we can double check our calculations. And a lot of times we don't get all of the information because, the people who are calling us, they're not necessarily as technically savvy. So, we would need like lines plans. We need schematics of the ship so we can try to model the ship as best as we can. And we try to estimate how much damage there is, because we might need to, do some section modulus adjustments, right? If the port side is somewhat damaged, you reduce the, section modulus in the area there to see if you have enough strength to be able to pull something back up. So it was interesting because it was a little bit of art and a science where you didn't have everything. So how can you get smart about making the problem as complete as possible? And you had to do it fast because you had to, summarize this to an admiral who had to make a decision whether or not to, save 100,000 gallons of oil or to let the ship break or to, endanger the coral reef. So it was one of those like 24/7 high pressure, high stakes job, but you did it with math and science, which I thought was cool. And being at Michigan and doing some of that stuff, and I think it was NA 410, no, 410 was structures. I think it was NA 470, the ship design course, learning about stability, learning about all of those different programs, using AutoCAD, all that stuff kind of comes together when, you need to be comfortable in the technical world to be able to do responses as quick as you need to do for, basically the world of the United States to protect our environment. So the CERT team was very, very, very good experience. Michigan, I mean, that was clutch. Most of us were Michiganders from Michigan that worked on the CERT team. So anytime somebody came from Michigan, it was like, yeah, you're a Michigan guy. Okay, you're on CERT. You were like, so definitely glad to be from Michigan and being able to jump in and do that stuff with CERT. So that's kind of the Coast Guard career and how Michigan came into my life. I mean, if it wasn't for the Coast Guard, I don't know if I'd be able to have known about Michigan and gone through it. So it was a really good time. But it didn't stop there. So for me, I after the Marine Safety Center, it's the most technical office you'll ever do as an officer if you're in naval architecture and in mechanical engineering. And so once I learned that after the Marine Safety Center, my job would be as an inspector, I wasn't as excited about being an inspector because I wasn't going to be able to use math and science as I'd been building up my career for. So I actually decided to leave the Coast Guard when they offered the fact that, hey, we have too many officers, you can resign your commission, we'll let you leave for 2 years, you can come back if you want. And for me, I was like, okay, I'll do that. And I wanted to see what other engineering was out there. So I ended up going to the Johns Hopkins University Applied Physics Lab, which is where I am today. My last day is today. And I was like a kid in the candy store because I had no idea this place does like everything. I mean, they do from ocean systems to cyber systems to land system to air vehicles to underwater to space. So for me, when I left the Coast Guard, I applied for a position in the ocean systems group because I talked to a recruiter there and he was like, hey, your resume, you have naval architecture background. We actually need people with naval architecture background for some of the rapid prototyping stuff that we're doing in our ocean systems group. And I was like, oh, really? So I ended up applying and getting into this position. And it was just, again, I had a great time. So for me, it started off as a mechanical engineer. But again, I had a naval architecture background. One of the first projects I got on was a wave glider. So I don't know if you guys are familiar with the wave gliders, but they're these autonomous unmanned surface vessels that have a float, which is right here. If you can see my cursor, it's about a 10-foot long by 2-foot wide surfboard that has a bunch of payload bays and antennas and stuff that skims across the water. And then it's got this 25-foot tether that has this submarine type vehicle with these gliding wings that actually pivot about a center point or center pin. And so every time this float goes up and down over a swell, this glider actually pulls the whole assembly forward because the wings are, picking up that pressure differential and pushing you forward. It even has, if you don't have any sort of any sort of wave action, you have a thruster here. It's actually not spinning, so you can't really tell, but this spins so you can push yourself forward from the bottom here and drag the float at the top. So this system, if you haven't heard of it, I totally just Google it, look it up. I mean, it's a really neat system. We do a lot of great things. And for us, we are actually using this for localizing nuclear submarines in the ocean when they launch their ballistic missiles in their test range. So I remember when I first got to APL, I was responsible for integrating all the sensors and all the payloads, building the stacks, 3D printing, and doing all that stuff with this system. Then we would pilot it out in Kwajalein. What they would do is the Navy would launch, in the Air Force at the time, because the Navy and the Air Force, they launched these ballistic missiles. So I think it was on land. So it was the Air Force that launched a ballistic missile from Hawthorne all the way out to Kwajalein, which is out in like Micronesia. And we actually took video, acoustics, and telemetry of the reentry vehicle splashing down in the middle of the ocean. with this wave glider system. And it was crazy because remember, I just got to APL, it had been like 2 months, and it's my first project that I got to do. But again, with being a Michiganer, knowing the naval architecture behind this and making sure everything is still stable as you're installing different weights and putting buoyancy. And we had a tow body too that actually dragged behind this glider. And so I had to ballast the tow body, make sure I removed foam in certain places, added weights in certain places, had flood holes. So all that stuff from Michigan was kind of neat how I got to use it. Again, math and science in this job. So that job was really cool, being a mechanical engineer. And then not only did we do stuff with maritime robotics, we were doing stuff with submarines. So, again, we would use this system up here in the top left to localize these submarines. But in order to localize a submarine, you had to install your own transducer on the submarine. And if you're going to touch a submarine, it's quite a process because you have to go through this huge certification process called a temporary alteration, which you work with NAVSEA. So a lot of folks in Michigan actually go work at NAVSEA too. So they'll be responsible for approving certain changes on some of these submarines. And so me, I was the one on the other side as a developer. I had to build some sort of a free flood pod. We had to install it on top of the submarine. I had to stay away from certain, electrical magnetic induction effects. I had to worry about shock and vibe. And we had to do all the drawings, make sure we tied into the right subsystems in the electrical power system on the submarine. We would go out to Bangor, we'd go out to Kings Bay, Georgia, and we would install these things. It would be like over a 2 or 3 day period. And again, after we install it here on the sub, then we'd have to go launch these wave gliders and then pilot them. So, at Hopkins, I never would have thought I'd be doing this stuff, but having a naval architecture background and also being a ship driver and then talking to the naval community in the submarine force, it was really easy to kind of understand how their operations would work because sometimes they'd have certain things they need to do in port that would restrict you from installing your stuff in the superstructure. So, having been on the other side as a former officer of the deck and knowing when to start and stop work, that helped a lot too. So that was one aspect of APL, which was really neat. And then, as I worked as a mechanical engineer, I did well and became a section supervisor. That was also cool because I got to develop the staff, do some career coaching. Because again, going back to my, the About Me section, I like to mentor people. And then, keeping the vision of what APL is trying to do relevant to what the work is going on with the staff was also great. And of course, conflict resolution. So those are some of the responsibilities that I would do even while I was a mechanical engineer, because as a section supervisor, I wasn't just the person approving things. I was still doing these other 2 jobs at the same time and being a mechanical engineer. So sometimes I'd have like a section suit meeting, then I'd have to go on an install and go do something out on the West Coast and then come back. Then I was a project manager on some other aspects. So if you see here, this is UAV that we were actually building an autonomous test tool to understand how to do V&V, so verification and validation of the autonomy for these unmanned aerial vehicles. So we were working with the Army, I was working with the Navy on their Triton system. We were building this software package. So I was leading a team of software engineers on how to build this, huge C++ type program using agile methods and making sure that we had the right autonomy from the sponsors and that we were building that within the right simulation to make it as valuable as possible. So as a project manager, I wasn't doing any of the coding, but I was definitely managing the architecture and the interfaces for how that kind of comes together. And that was kind of a fun project because a lot of my PhD type work dealing with stakeholder needs and overall, the V&V of autonomy and understanding how to develop autonomous behaviors, all that stuff came into effect with the project manager role that I was doing with the, it's called RAP, is a range adversarial planning tool that we were building for the Army and the Navy. That tool is supposed to go out to many other autonomous systems, so I'm very excited about that. And then not only was our project manager, section supervisor, mechanical engineer, but it's also a technical lead on a lot of other projects at the same time. So one of the cool things we were doing when I got there, we were actually helping out with the Navy's submarine rescue system. So I don't know if you guys are familiar with that system, but basically it's a system that the Navy has built to save disabled submarines when they go down and they hit the bottom and the sailors are trapped inside. So what they would do is they had this large system, and it's a system of systems. You have, this is called the PRM, the Pressurized Rescue Module. It's crazy because this is actually teleoperated through a Connex box on deck, and this has an umbilical that goes down. So what they'll do is they'll lower this down, thousands of feet, and then they'll have this rescue bell here that mates to the actual hatch of the submarine. They'll pump it out and they'll make sure it's equalizing pressure. Then the people on the inside of the submarine will open it up and crawl up through here. This will take up 20 or so people at a time. And this vessel here, again, this goes back to where the Navy contracts with other entities, other shipyards, other commercial, vessel carriers. What they call these vessels they're called VOOs, VOO, which is Vessel of Opportunity. What they'll do is they'll fly this large rescue system, which is composed of the SRS. They even have these things called the ADS, which is like an automatic diving system. So it's think of like a astronaut suit, but it's for a diver. And then they have rescue bells. They'll have the transfer under pressure, the TUP, which is like 3 different Connex boxes that all get kind of mounted on a random ship. And I say random ship, but it's not as random because there's ABS standards that allow a certain level of deck reinforcement for the system to be installed on. So for me as an APLer, they needed help assessing how to best either update the system, build a new system, or reconcile the old system. And so I was very familiar with the ABS rules, being at the Marine Safety Center from the Coast Guard, and also doing stuff from Michigan to be able to understand what all that stuff means. So as nice as we were a consultant for a lot of these systems, they flew me out to I think it was Singapore, and then Foslene in the UK, and then Australia, to go see that there's another, is Merlo, which is like this international submarine rescue group. They have different rescue systems throughout like 7 or 8 different countries. So what we would do is we would fly out, assess the other rescue systems, and try to understand where the strengths are, where the weaknesses are, and see what the US needed to do to their system to make it better. So it was a really cool project because, again, naval architecture is involved, ABS is involved, all of that stuff. And again, not a lot of people know about APL. We do a lot of really neat things. So I'm just trying to share that with you guys in case you're interested in, joining them or seeing what's out there. So that's a submarine rescue system. We also worked on a lot of projects related to the Virginia class submarine, which is the new submarine they're trying to build for the Navy. So there's a lot of different areas going on there. A lot of people working up in Groton, where the submarine bases are. So there's other opportunities from, being a Michigan person, go up there and do naval architecture. And then for all that stuff I was doing in the Ocean Systems group, I eventually, because I was passionate about space exploration the whole time, I was actually working on an IRAD, which is an internal research and development effort at the lab on synthetic aperture radar for space-based systems. So we were developing a constellation of different satellites that would move in formation flying patterns to do different detection techniques, such as like moving target indication and point cloud mapping. So we were doing all that while I was in the ocean stuff, but then that also led me into switching over to the space sector. And in the space exploration sector, I was working on DART, which, if you guys are familiar, DART was a double asteroid redirection test that just went up not too long ago. And we're trying to go send this spacecraft to the Didymos system so we can actually perturb the smaller asteroid, change its trajectory, and try to measure the change in the period to help with planetary defense. So for me, I was in the fault management group that was writing software scripts to make sure that the autonomy kicked in whenever we would experience a fault. And so that was also related to some of the PhD work that I was getting into for systems engineering, dealing with autonomy, which is also related to some of the stuff that I was doing in the UAV work. So it was really neat to see how this stuff kind of worked and worked out together. But even as you're doing your naval architecture work, whenever you have opportunities to code, like, again, I think Matt Collette was doing that TLP optimization project. I don't know if he's still doing it, but we had lines and lines of code to do particle swarm optimization. Take advantage of that to learn how to code and do as much as you can, because you never know when you're going to need those skills again. So definitely great to have been a part of this curriculum at NAME to get ready for this stuff. So that's Hopkins. That's what I do now. And so now on Monday, I start doing astronaut training, and super excited for that because, you know, I've been wanting to be an astronaut since I was like 7. So some of the stuff we'll do is, you know, if you've seen the stuff online, there are 5 major components of the training. So on the bottom left here, we fly T-38s. And so for me, I'm a non-pilot. So what I'll do is I'll go to Pensacola for flight school first. And I'll have to learn on the Navy's T-6. It's like a training craft. And then I'll do that for about a month and maybe 2 months or so. And then I come back to NASA and I'll fly the T-38s as a backseater. As you see in the picture here, there's a backseater, which will be me, and there's a front seater. The front seaters are pilots that, you know, they're typically coming from the Air Force, the Navy, the test pilots that have thousands of hours of experience that are very comfortable in the aircraft. And it's kind of cool because even when we're done training, we have to maintain qualifications. So I think we have to do like 10 hours a month. And sometimes, like when we have to go to other NASA research centers, we'll just fly the T-38 instead of commercial so we can keep our qualifications up. So I thought that'll be pretty neat, even as after training. And so also we do robotic systems training. So we have to learn how to do the robotic arm. This is Shane Kimbrough. He's doing it from the ISS, but we'll do training on the ground. I think even sometimes we go to Japan to do the robotics training, but depending on COVID situation, we'll see how that goes. We also do underwater spacewalks. So these are called EVAs. And you have to do these. I mean, they're pretty intense. I'm looking forward to it, though. It'll be a good challenge because like it's a 9-hour spacewalk. They'll put you in this suit. And this pool here is the neutral buoyancy lab. So what they try to do is they try to make sure you're neutrally buoyant to, you know, simulate 0G. I know it's not perfect because, you know, you'll see the bubbles when you're upside down, floating up or floating down, but it's close to 0G as we can get with the spacesuits on. And these spacesuits, they're like 200 something pounds. So you're gonna have to fight the inertia of the suit, inertia of you, and inertia of the water, right? Those added mass coefficients, you know, damping. So it's going to be a challenge, but it'll be a lot of fun. And this pool is really big. It's like 200 feet long by like 40 feet wide. I can't remember the exact dimensions. And they have a mock-up of the ISS underneath. So you're simulating as if you're going outside the ISS, repairing certain modules and coming back in. So you do about, you know, I don't know, maybe 10 or 12 spacewalks, 9 hours each. And they say eat a big meal before you go in so you don't get fatigued throughout the walk. So it'll be a challenge. And we have general space systems training for the ISS. So learning all the different modules, what they do, what the Capcom does, all the mission control folks will do that. And then what's not on here is we'll also do, excuse me, Russian language training. So every astronaut needs to learn Russian because we'll interact with potentially the Soyuz, which launched us up for a while. We didn't have any other vehicle. There's also, sometimes some of us get sent over to the Russian mission control. And, you know, that's always like playing with others is good, right? And being able to interact and swap out with other countries is going to be the new norm, because even for our class, we have 2 UAE astronauts that'll train with us. I think after the training, they'll go back to their agency, but, you know, we're all in this together. So it'll be fun. So with that, I believe that's it. If you guys have Q&A, I welcome it. So thanks for having me. Cool. I don't know if anybody's speaking, but I can't hear anybody.
How do we ask questions, Lisa? Just yell them out, or
If you raise your hand, I'll just follow you. Okay.
hi, what was it like applying to be an astronaut?
Yeah, good question. So it was definitely an event, an ordeal. It was not trivial. So if you guys aren't familiar with it, you typically apply through USA Jobs. And in USA Jobs, there are like 5 categories. I don't remember the exact ones, but the one I applied for was the engineer/operator. And then there's like a physicist one, there's a test pilot one, there's like a pilot one, and then like a medical doctor one, I think. So when you go through that process, make sure you're trying to fit the category they're asking for. So I've noticed a lot of people try to make up their own strength or weakness to those categories. And at that point, right, it's 12,000 people that they had to get through. If you don't line up with exactly what they're looking for, it's easier for them to not put you in the pile. So going from 12,000 to 120 is a first round application from computer to people. And then when you go to the first round interview, you know, there's 120 of you. There were like, I don't know, 5 groups of 20, I think, or 6 groups of 20. They split us into groups of 10. So it was like crazy logistics because like each week there were 2 groups. I was like week 2, group 2. And you do group interviews where you're all doing your psychological testing, you do your regular interview, you do some physical tests, I think, and you do some familiarization. So I can't talk about it too much because there's an NDA, but I can do the high level stuff. So, but once you get through that first one, typically in the past they do 3 interviews, but this last year they did 2 because of COVID. So they went from 120 down to 30. So the final interview, that one was definitely more intense. They did, you know, more psychological interviews, another technical interview, and then other assessments to make sure you're mechanically inclined, that you can work with people, and that you can handle certain situations. So that's the overall process. It's more than just, you know, how's your resume look? It's, can you play well with others? Can you know, think quickly on your feet? Can you problem solve in real time? And that's a holistic process that you want to get ready for if you're interested.
Cool, thank you.
You're welcome.
Was that kind of always the plan, where like building your career towards this path?
So that's another good question. The way I like to describe it is, for me, as I mentioned in my About Me section, you know, I was passionate about space exploration, period. And like, even for Hopkins, I was just so thrilled to become a space systems engineer that I was happy. So when I was a kid and I started realizing like, hey, math and science comes easy to me. Oh, hey, I like Star Wars. I like these, you know, space thing. I like black holes. I like nuclear fission. I like physics. So it was kind of like I had this vector, right, in mind of going towards space exploration, whether I was going to do it as an engineer, as somebody that was going to be like flight operations control person at some satellite station or whatnot. I wasn't necessarily like, I have to be an astronaut or nothing else. It was like, I wanted to go towards this direction. And then as I started picking up skills along the way, and as the applications started coming out, I was like, hey, let's go for it. And so that's how I see it. And I think, I feel like that's one of the more tractable ways to do it, so you don't put so much pressure on yourself. I mean, at the same time, like, everybody who's involved in the process has likely applied more than once. I don't think I've ever seen anybody or talked to somebody who just applied the first time and got it. So it's definitely a life commitment too, because, you know, NASA, they tend to look for people who've applied multiple times to know they're serious about it, because it definitely is a life-changing event. So, but yeah, that's the overall, you know, approach that I thought through, if that makes sense. Any other questions?
Okay, well, if there are no more questions, thank you, Andre, for coming to present to us. Greatly appreciate it.
Sounds good. No problem. Let me know if you guys have questions or have any future talks. I'd be happy to help. And you guys have a good day.
Thank you so much.